Hello guys, welcome to my YouTube channel. Today we will be discussing how to calculate the quantity of steel reinforcement in a slab. Not wasting our time, let's begin. I will explain you few steps how we will calculate the quantity of steel by choosing an example. So first of all, as you can see here, I have given a diagram here. In the diagram it's clearly mentioned that the length of slab is 7 meter and the width of slab is 3 meter, and the diameter of the main bars is 12 mm with spacing 150 mm center to center. And we talk about the distribution bars, that's also 12 mm dia and spacing is 150 mm center to center. So most of the students get confused how we can convert the mm into the inch. For example, we have in site we have to deal with the inch and fits, so we will be changing how we will convert mm to inch. Simply we have to divide that by 25.4, as I have shown an example here. 150 divided by 25.4, that's equivalent to 6 inches. And one more thing, the main reinforcement is provided along the shorter span and the distribution steel is provided along the longer span. I will explain you why. Because as we see in step 1, type of slab, we have to check which type of slab it is. So when as per IS 456 2000, when length of longer side to the length of shorter side is greater than 2 or equivalent to 2, that time we have to design it as one-way slab. In our case, if we see that Ly by Lx is 2.33, so it is greater than 2, so we will design it as one-way slab. So what is the main criteria or what is the basic function of the one-way slab is that we provide the main reinforcement along the shorter span and the distribution steel along the longer span. So I think it will be clear till this point. So we will explain how many bars of main bars will be required and how many number of distribution bars will be required. So moving further, number of main bars is equivalent to total length divided by spacing plus 1. So main bars we are providing along the shorter span, so it will be 7 divided by 0.15 plus 1. So I have taken here 7. Why I have taken here 7? Because we are moving along the longer direction. We are providing in shorter span, but we are moving along the longer span. That's why I have taken 7 here. So it's come near about 48 bars. In the similar manner, we will calculate number of distribution bars. Distribution bars also equivalent to total length divided by spacing plus 1. So here total length will be 3 because we are providing distribution bars along the longer direction, but we are moving along the shorter span. So that's why I have taken here 3. So that's why it comes out to be 21 bars. So moving further, now we will calculate the length of main bars. What will be the length of main bars? That's equivalent to width of slab. What is the width of your slab multiplied by number of bars? How many number of main bars are required, which we have found in the last slide. So it will be 3 multiplied by 47. So length of main bars will be 329 meter. I think it's clear. And if we calculate similarly length of the distribution bars, that's equivalent to length of slab multiplied by number of distribution bars, which we have already calculated. So it will be 7 multiplied by 21, that's 63 meter. So total length of steel, what is the total length of steel? So that is length of main bars plus length of distribution bars. 329 plus 63, that is 392 meter. Calculating the quantity of steel, how much quantity of steel will be required, because this is the main point which we will require. So to calculate the quantity of steel, we have formula d square 162.2 multiplied by L. L here is length and D is diameter of bars. We will calculate separately quantity of steel for main bar and separately quantity of steel for distribution bar. So firstly, calculating the quantity of steel of main bar. So it will be 12 is the diameter we are using on main reinforcement, that's 12 square divided by 162.2 into length. Length we have already calculated how much length was required for the main bar, that was 329. So it's coming out to be 292.08 kg. So again, quantity of steel of distribution bars, that's again 12. We are choosing the 12 mm dia, 12 square divided by 162.2 multiplied by 63. So it's coming near about 54 kg. So now what is the quantity of steel? That's for main reinforcement and distribution reinforcement. That's coming out to be 293.54 plus 54. That is 347 kg we are getting here quantity of steel. So we need to add some wastage also. So we're taking the wastage of 5%, which is near about 18 kg. So the total quantity of steel required will be 365. So total quantity of steel reinforcement for this example which I have taken here, that will be 365. Now we need to know how to calculate the quantity of cement, sand and aggregate. I have already make a video on that and explain all the steps. If you haven't watched that video, go and watch that video and link will be in the description. So if you like our video, so like it, share it and subscribe it. Thank you so much.